Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, you are welcome to the 9th edition of our online mathematics class. Today we want to quickly round up the topic we have been doing so far, and the last subtopic under that is definite integral. Mind you, all the integration we have been doing so far, they are what we refer to as indefinite integral. But this morning, inshallah, we want to look at definite integral. Why is it definite? It has been defined here as an expression of the form integral from a to b, f of x dx, is called a definite integral. Why? Because it has limit of integration from a to b. This a is called the lower limit, while this b is called the upper limit. So a and b are called the limit of integration. So whenever you have an integration of that form, such that you are integrating from certain number, from certain lower limit to certain upper limit, we call it a definite integral. Definite integral. An example is given on the board. Example 1. Evaluate the following. We have integral from 1. That means the lower limit here is 1. The upper limit here is 3. From 1 to 3. 4s cubed plus 3. 4s cubed plus 1. 4s cubed plus 1. This is 3. This is 4s cubed plus 1 dx. Then the second one is integral minus 1 to 2. 4 minus 5x raised to power 4 dx. Then the third one is integral from minus 2 to 3 x raised to power 4 plus 1 all over x squared dx. Then the last one is integral from 0 to what? Pi over 4. What I have here is what? Is pi over 4 6 cos 2x dx. Solution. I will start with the first one. A that said integral from 1 to 3. We have 4x raised to power 3 plus 1 close bracket dx. If you want to integrate this is normal integration of the polynomial, and that is what? 4x raised to power 4 all over 4 plus x plus c, where c is the constant of integration, and from 1 to 3. From 1 to 3. Look at this. If you integrate 1, you have x, with regard to x, you have x. If you integrate 2, with regard to x, you have 2x. If you integrate 3, with regard to x, you have 3x. If you integrate 4, with regard to x, you have 4. I think I don't need to explain that much, because I told you when we started integration. So, you substitute the limit of integration, but before we do that, we can say that this and this can go. So that we now have this to be equal to x raised to power 4 plus x plus c. Then from 1 to 3. So we can now substitute our limit of integration, and this is equal to what? 3 raised to power 4 plus 3 plus c. Close the bracket. That is when you substitute 3 into this, minus when you substitute 1. If I substitute 1, I have 1 raised to power 4 plus 1 plus c. So this is what I will have. And this is equal to, don't forget, 3 raised to power 4 is 81 plus 3. 81 plus 3, that is 84 plus c. Minus this one, 1 raised to power 4 is still 1 plus 1, 2, then plus c. At the end of the day, you subtract, you are going to have this to be equal to what? 84 minus 2, that is 82. C minus c is 0. That is why whenever you are dealing with what? With definite integral, the constant of integration will always vanish, because you substitute the limit of integration, and by the time you are substituting the limit of integration, the constant will disappear. So that is that. The second one, question B, which is integral from minus 1 to 2, 4 minus 5x everything is power 4 dx. Don't forget, I've told you that we are going to use algebraic substitution to integrate this, because ordinarily if you want to differentiate this, you're supposed to use what? Chain rule to differentiate it. And any problem like that, if you want to integrate them, you need to use what? Substitution method or algebraic substitution method. And what we are going to do is that to say let u equal to 4 minus 5x, you find your du all over the x to be equal to minus 5. You will cross multiply. Du will be what? Minus 5 dx. By the time you divide both sides by what? Minus 5. At the end of the day, your dx will be equal to du all over minus 5. So that by the time you substitute into this, you are now going to have integral from minus 1 to 2, close, open the bracket, 4 minus 5x, everything is power 4 dx, is now going to be integral from minus 1 to 2. The whole of this is what? Is u. So u raised to power 4 multiplied by the x. What is the x? The x is going to be u over minus 5. That means the u all over minus 5. So that is what we are going to have. And you can factor 1 over minus 5 outside. If you factor 1 all over minus 5 outside, you are going to have it to be equal to 1 all over minus 5. Open the bracket from minus 1 to 2. U raised to power 4 the u. This is what you are going to have, so that you can now integrate further. If you integrate further, you are going to have, by the time you integrate u raised to power 4 whatever to u, you have u raised to power 5 over 5 plus c. That c will now be the constant of integration. So this is going to give you which is equal to what? 1 all over minus 5, open the bracket, u raised to power 5 all over 5, u raised to power 5 all over 5 plus c, close the bracket, from minus 1 to 2, from minus 1 to 2. So if I like, I can have it as over minus 25 if I like. If I multiply it with constant, I will still have constant. So the best way to do this is just, since I know when I substitute the value of the constant will vanish. I can easily eliminate constant if I like, if I so wish. And if I like, I can have this as this to be equal to, open the bracket, you are going to have what? U raised to power 5 all over minus 25, then plus c, close the bracket, minus 1 plus 2. Why did I? Please take notes here. I did not multiply 1 over minus 5 with c, because any number multiplied by constant is still a constant. Don't forget, this is a constant of integration. If I want to do that, I don't know, because it will definitely vanish. Even though if I multiply it and I have minus c over 5 or c over minus 5, by the time I substitute the limit of integration, they will still vanish. So take note. Constant is always constant. If you have a constant c and you multiply it with 2, it's still c. Don't forget. So take note. So at the end of the day, I will have to substitute that. So I can have this as u raised to power. What is our u initially? Our u is 4 minus 5x, close the bracket, raised to power 5. Everything over minus 25. Then from minus 1 to 2. C will vanish. So I don't need to waste my time including plus c. And this, of course, is going to be, when you substitute 2, you are going to have, if you substitute this, you are going to have 10. 4 minus 10. 4 minus 10, that's minus 6. That means you have minus 6 raised to power 5 all over 25 minus. Then minus, if you substitute 1, minus 1 here, you are going to have what? Minus plus 5. Plus 5, that is 9. I'm going to have 9 all over minus 25. This is what I'm going to have. Look at it very well. If you substitute 2 into this expression, you are going to have 10. 4 minus 10, it is minus 6. This power 5, this power 5 over 20, minus 5, minus 5. If you substitute 1 to this, you are going to have minus 1 times minus 5. And that will be what? Minus 1 times minus 5. And that is what? Plus 5. Plus 5 plus 4. That is 9. Over minus 25. Over minus 25. Minus. That's what you are going to have. And at the end of the day, I'm going to have minus 6 raised to power 5 all over minus 25. Then plus 9 all over 25. If you do your calculation very well, you are going to have 2, 6, 7, 3. You do your calculation very well. That is, don't forget that this is an even power. By the time you raise minus 6 to the power of this, you are still going to have minus in your answer, and that minus you cancel this minus. You are going to have, and the SM of the numerator is 5. So it's as good as having what? 25 at the SCM, then this plus this, and that's what it's going to give. And that is that for the second one. I hope that is very clear. I'm very happy I'm taking SSS3. So you don't need to be told how to add 1 plus 1 to add 2. C. What I have in C is integral from -2 to 3 x raised to power 4 plus 1 all over x squared dx. If you have a problem like this, you are going to split it, and you are going to have this -2 to 3 x raised to power 4 all over x squared plus 1 all over x squared dx. And this is equal to integral -2 raised to 3, open the bracket. This and this is going to have x squared. Don't forget. And this are going to have plus x raised to power -2 and dx. Don't forget. Another law of indices, when you have 1 over x raised to power m, same thing as x raised to power -m. And that's why I have this as x raised to power -2. And don't forget that this and this, the same thing as you have, of course, to remove 2 power, because x raised to power 4, the same thing as x times x times x times x in first time. And x raised to power 2, the same thing as x times x. So these and this will go without 2, it remains x times x, which is x squared. And that was how I have it. So you can now integrate. If you integrate this, you are going to have this will be what? X raised to power 3 all over 3. If you integrate this, you are going to have what? Minus 1 over x. 1 over x plus c. Why is it so? You have x raised to power -2. You want to integrate it to be plus 1 all over -2 plus 1. And this is going to be what? X raised to power -1 all over -1, which is empty as -1 over x. And that was how I got an example right here. So take note of that. So that is that. So limit of integration is from -2 to 3. So what we need to do here is to substitute for when x is equal to 3 minus when we substitute for when x is equal to -2. So let's go here. Let's go there. So this is equal to, when you substitute for x raised to power 3, you have 3 raised to power 3 all over 3 minus 1 over 3 plus c, close the bracket, minus, when you substitute for x raised to power -2, you have what? -2 raised to power 3 all over 3 minus what? 1 over -2. Then c plus c, of course, plus c. So this is equal to, don't forget, this is what? 27. And by the time you do that, you have 9 minus 1 over 3 plus c. That's what you are going to have. Because this will be 27. 27 divided by 3. That is 9. Then minus, of course, this will be 8. Minus 8. Minus 8 all over 3. Then this one will be plus 1 all over 2 plus c. So without wasting much of our time, we know that here, if I do the analysis here, I have 27 minus 1. 27 minus 1. And that's 26. So we have 26 all over 3 plus c. Close the bracket, minus. Here, the SM here is 6. So I have 6 all over. This and this will be what? Minus, that is what? 2. That is minus 16. Plus, this and this, 3. Close the bracket, plus c. Or rather 2 plus c. And what I'm doing is that, don't forget, what I've done here is that this is divided by this. The SM of this and this is 6. This is divided by this, of course 2. You can go divide with minus 16 plus this is divided by this, what? 3 times 1, 3, 10 plus c. Don't forget that this c and this c will go, and here I have 26 all over 3 minus this and this, of course is going to give me what? Minus 13, and this one will make it plus 13 all over 6, and this, the sum of this is still 6 all over, this and this will be 2 times this, that is 52 plus what? 13 all over 6, and that is what? 65 all over 6. So if you like, you can do it as what? 10 whole number 5 all over 6. So it's still the same thing. So that is that about that. I hope that is very clear. Just look at it very well. Look at it very well. It's very straightforward. It's not difficult. So the last one that I'm going to solve, which is D, the D part. The D part. What I have in this integral from 0 to pi all over 4, 6 cos 2x dx. That's what I have in the last part. Don't forget that pi is 180 and pi over 4 will be what? 180 over 4, which is 45. But that's not where we are going. Where we are going is that if I like, I can write this as 6. I can bring that 6 out. And I have integral from 0 to pi all over 4 cos 2x dx. I can write it like that. And don't forget, if you integrate cos x, you are going to have sin x. If you integrate cos x, you are going to have sin x. If you integrate sin x, you are going to have minus cos x. But if you integrate cos x, you are going to have sin x. But if you now integrate cos 2x, you are going to have what? 1 all over 2, then sine 2x. Don't forget that because integral of cos ax dx, the same thing as 1 over a sine ax plus c. That's the identification. So note, you should know that. I don't need to be wasting my time and using substitution or method of substitution to be explaining this to you. So this is the same thing as what? 6 multiplied by 1 all over 2 sine 2x then plus c. So close the bracket from 0 to pi all over 4. This is what I'm going to have now. This 6 is this. Integral of this is the whole of this, then plus c. And that's what I will have. And I don't need this and this can go, so that I can now have this will be 3. I can now have 3 sine 2x plus c. Then from 0 to pi all over 4. So that's what I have. So I can now substitute my limit of integration now. When x is equal to pi all over 4, and when x is equal to 0, and see what I will have. So this is equal to 3 sine 2 multiplied by pi all over 4 minus, open the bracket, 3 sine 2 multiplied by 0 all over, okay, 0. So that's what I. Don't forget, that's what I'll have. So take note of that. So of course, this is equal to sine 0, of course it will be 0. So I don't need to waste my time because these 2 times 0 here will be 0. 3 multiplied by sine 0, everything here will be 0. Here I will have 3 sine, this is 180. Of course this and this will go. I have 2. So I now have what? 2. That is what? 5 all over 2. And 5 over 2 is 90. So I have 3 sine 90 degree. And what is sine 90 degree? Is 1. So my answer will be 3. And that's what I have. Cos 90 degree is 0. Sine 90 degree is 1. So that's what I've done. I hope that is very, very, very clear. So if that is clear, then you can say bye to integration as a topic. So inshallah, the assignment I'm going to give you, I will just give you 3 questions or 4 questions to solve on this. So that assignment is going to be created on the school website. So please make sure you check and you solve. So inshallah, in our subsequent class, we are going to look at the very important topic that we have not done. It's only those that are privileged to be doing further mathematics that have done it. For those of you that have not been doing further mathematics, we have not done that topic. And that topic is permutation and combination. You have not done in mathematics, and it's also important. It has been included in the syllabus of mathematics. So it is important that we do it. So in our next class, inshallah, we are going to look at permutation and combination. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. سبحان ربك رب العزة عما يصفون والسلام على المرسلين والحمد لله رب العالمين.